Welcome to Microsoft Security Risk Detection. Today, you will see how to use Microsoft Security Risk Detection to find million-dollar bugs using the same technology Microsoft uses for testing our own products and services. This technology creates a fuzz lab in the cloud with support for both Windows and Linux. To get started, visit www.microsoftsecurityriskdetection.com. That will show you the portal for Microsoft Security Risk Detection. The portal is your one-stop shop for controlling security testing and viewing what has been done in security testing. Today, we're going to focus on the fuzzing part of the portal. We have a separate video for talking about the web scanning part, which we'll discover later. Today, I have 3 fuzzing jobs. A job is one piece of software being tested in one lab. One of the jobs is starting to initialize. One of the jobs is ready for me to upload software for fuzzing, and one of the jobs is already underway. I will talk to you first about the results you get from fuzzing and how to look at the progress of a job. Then we will see how to submit a job, how to configure it, and how to create a whole lab running in the cloud of your very own to attack your software before hackers do. Let's look at this job. It is currently fuzzing. It started on the 18th of March 2019. The job already has 17 results. Let's click on the results page and see what the results look like. Microsoft Security Risk Detection is throwing millions and millions of test cases at your program. This program is called Calendar Reader. Calendar Reader is a wrapper around a library called Calendar Lib. Calendar Lib is a library that reads those cal files which we all use to infect each other's calendars. Now, over here, I can filter out all of the results by severity. I can see crashes, meaning that the program actually crashed, or I can see first chance exceptions, which means something happened but the program was able to continue without crashing. I'm going to focus on the crashes. I click on the crashes and boom, I can see all of the things that caused crashes. So I can see here there are 3 what we call buckets. The first bucket is a divide by 0. The second bucket is a read access violation. And the third bucket is a read access violation. These are the types of issues that were found by the fuzzing process. So here, a divide by 0 means that the program crashed when attempting to divide by 0, whereas read access violation means that the program attempted to read memory it should not have been reading. Here, I can also see that the read access violation has a small marker saying that we believe this violation is exploitable. If an attacker found it, the attacker may be able to use this to take control of your computer or someone else's computer running your software. I'm interested in the exploitable violation, so I'm going to go ahead and click on the link here and learn more about it. When I click on the link, I see 3 things. I see the call stack where the problem was found. I can see the instances showing me information on how many times this has been found during fuzzing. In this case, it's been found 1, 2, 3, 4, 5 different times by Microsoft Security Risk Detection. Microsoft Security Risk Detection is deduplicating different issues and attempting to find issues that have the same root cause. So these are 5 different test cases which we believe have the same root cause. And finally, I can see the debugger logs right here in the portal showing me what happened. In the debugger logs, if I scroll down, I can see that there's some access violations which were first chance. They were handled. The program continued. And then here I see, oops, the access violation, the memory is being read that should not be read. And here it's a second chance and the program is completely crashed. And I can see the complete call stack where the crash happened. And I can see more information about what has happened to the program. Now, if I want to actually get the test case that caused the crash, all I have to do is put the download button here. Microsoft Security Risk Detection captures every single test case that causes a crash. Microsoft Security Risk Detection reruns the test cases multiple times to see that they can crash over and over again, so you have confidence before reporting them to your colleagues and asking them to fix something. When I click the download button, I get a zip file that contains information on the crashes. Let's open the zip file and see what that looks like. I'm opening the zip file, and inside the zip file, I see 5 different cal files. So remember, we're testing today something called Calendar Reader. Calendar Reader reads .cal files. Each of these 5 different files, if fed to Calendar Reader, would cause the same crash that was reported in the portal for Microsoft Security Risk Detection. We have an API, not shown in this video, which allows you to programmatically download all of these different cal files and then send them to your colleagues. Later, you will see how that API is used under the hood to do integrations with Azure DevOps and Microsoft Teams to help you and your colleagues more effectively use Microsoft Security Risk Detection in your workflow. So the zip file contains the 5 test cases that all cause this specific problem in a folder called crashes. And if I look in the folder called crashes, it says, okay, it's a read access violation. This number is called the hash. The crash hash is a unique identifier for the specific issue that was found by Microsoft Security Risk Detection. This is a unique ID which distinguishes this issue from other read access violations or other issues found in the same program. And now I can see for every one of those 5 input files, there are logs which allow me or my colleagues to understand better for each of these 5 input files what exactly has happened. And inside I can see a script that reproduces the issue, the output of the Windows debugger, the standard error, the standard out, and some metadata about that. So here, this gives me everything that I need in order to understand more about what exactly has happened to cause this particular issue. I'm now going to close this, and I'm going to show you how you can create a new Microsoft Security Risk Detection job just like this one that helps you find issues in your code. So what I do is I'm closing this. I click on the Security Risk Detection link up here at the top. This takes me back to the dashboard. And at the dashboard, again, I can see all of the jobs I have created for testing my Windows software or my Linux software. Here you can see one of the jobs currently underway is a Linux job. That means it's testing Linux in the cloud. And these other 2 are Windows. So how do I create a job? It's pretty simple. I push the button called Create Job. Microsoft Security Risk Detection offers 2 methods for creating jobs. In one method, you have complete control over the entire virtual machine which is used for submitting a job. You can install kernel drivers, you can change registry keys, you can do whatever you want. Alternatively, some applications fit into what we call a package. A package is a zip file that contains everything you need in order to fuzz. Package submission is faster. Package submission allows Microsoft Security Risk Detection to more quickly spin up a lab, but we found some customers need the flexibility of the full virtual machine. If you are in doubt, talk to your your application development manager or technical account manager for guidance on which one is right for you. Today, I'm going to remote to a virtual machine, and I am going to pick the standard job tier. We have on Linux, we support the AFL testing method. It's one of the portfolio of fuzzers that Microsoft Security Risk Detection uses. But today I'm going to use the standard tier, which gives me the best optimized lab size and composition for testing applications. I now have a choice. Do I want Server 2008, Server 2016, or Linux, Red Hat 64-bit? Today I'm going to take Server 2008 R2. I'm going to create a job, and you can see that the job is now starting to work. It's initializing, and I get a notice here saying what my quota looks like, and if I'm running low on jobs and if I need to do more. Well, I've already created a Windows job, so now let me show you what that looks like while we wait for this to initialize. Under the hood, Microsoft Security Risk Detection is spinning up a machine in the Azure cloud just for you, just so you can put anything you want on that machine, and a Microsoft Security Risk Detection can run millions of test cases for you. But how do I get started? Well, I get started by clicking on the Open link. The Open link for the job lets me see the status of the job and gives me the ability to log in to a virtual machine in order to configure it for testing. So I've clicked on the Open link. I see the overview, which tells me about the job, what kind of operating system it is, when it was created. I'm going to click on the Preparation link. The Preparation link gives me a username and a password for remote desktop information to the machine. So I'm going to click this Remote Connect, and Remote Connect is downloading an RDP file, a Remote Desktop Protocol file. I'm going to open that, and it connects me to a machine in the cloud. So I can see here, I am connecting to a machine using the Remote Desktop program that is built into my copy of Windows. My username is customer. That matches the username here. And for password, I can click the copy link here. It says click to copy. It says copied. Now I can just go ahead, go straight back to RDP. I'll hit the remember me so I don't have to enter this password again, and click OK. And now I'm securing the remote connection. I'm getting everything set up in order to connect to the machine in the cloud. And it just gives me a second while I get access to a machine that has been created just for me in the Azure cloud, just for the software I want to torture today. I now am connecting to the machine. And what I've done on the side here is I've actually created already pre-provisioned the calendar reader application I want to test. So what I have is I have downloaded and made ready the calendar reader application that I want here, and we're going to copy it over to the virtual machine, and we're going to test this calendar reader application. So in just a few minutes, the machine boots up, logs me in, creates my account, and gets everything ready for first use. So while I'm doing that, I've got my calendar reader application, I've got that ready. And then fuzzing also requires what we call as seed files, which are some initial unit tests or initial information that is used for starting the fuzzing process. Well, that's okay, because I've already got those as well. I have here a bunch of cal files. None of these cause crashes, but these are all part of my unit tests, my functionality tests for my calendar reader program. So all I have to do is get at least one of these, more the better. Under the hood, our system will make sense of anything that you end up giving it by using code coverage in order to pick the best set of seed files. And then over here, we're just waiting for the machine to get started. So while I'm waiting for the machine to get started here, I can go ahead and extract all of the files that I have for my seed files. And I'm just going to open them with I'm going to just go show you what's inside of one of these just by opening up with Notepad. This is an example of one of my seed files. So your software is going to be different, but this is an example of what one of those files looks like. It's just a standard cal file. It happens to be referring to an interview or a meeting with a fellow named Spartacus Smith, spartacus@contoso.com. So we can see here that we're preparing the desktop. We're getting ready for first use. And if I want to, I can even just put this into a window while I go and take a look at the rest of what's happening on my machine. So here we are. We're getting ready to start our fuzzing process by configuring the virtual machine and configuring the virtual machine with the software that we want to test. So we're preparing our desktop. We're getting ready. And then now we have finished logging into the machine. The machine shows us some additional information up here: deployment ID, IP address, when it was booted, free space, and I can see that this machine was created just for me. It has 3.5 gigs of memory, which I can use to install whatever I want. And then now I see the Microsoft Security Risk Detection Wizard. The Microsoft Security Risk Detection Wizard walks me through everything I need to do in order to submit software for testing with Microsoft Security Risk Detection. Now, the first thing I need to do, I need to upload my software to the machine. If I read through, it says, okay, program files is not a valid install location for the entry point executable. The entry point executable is the specific executable I am going to test. Today, that entry point executable is the calendar reader, which I just showed you, which is the actual exe file that I want to find issues in. So it says, we recommend you install it into the C app directory. Okay, well, what do I need to do in order to do that? I need to open up Explorer. I open up Explorer by clicking on the Windows Explorer link here. I go to computer. I go to local disk. There's a directory called C app. There's nothing in it. I haven't yet installed my application. But remember, I have queued up my application. I've already built it. We'll talk later in a separate video about how to use Azure DevOps in order to seamlessly automate this process by creating a build task that just uploads everything and submits it for you. But in the meantime, what I have done is I have created a folder here, and this is a folder on my local machine. My local machine folder is my executable, my PDB, so I can get more information about the results, a DLL, which this particular executable is wrapping, and I have another PDB file for the full thing. So what I can do in Remote Desktop Protocol, I can copy and paste. I'm going to copy from my local machine, and I'm going to paste into the remote machine. And through the magic of Remote Desktop Protocol and the magic of Windows, I am able to actually move those files from my local machine to the machine in the cloud. So what I've done is I've taken the software I want to test. I've taken it from my local machine where I compiled it and made it ready. I've put it into the app directory, the C app directory on the cloud. And now I'm going to go next. I'm going to go click next on the wizard. So it says, great, I'm ready to go. I click next. What do I need to do? I now need to tell the wizard what application do I need to run during fuzzing. So what will happen is Microsoft Security Risk Detection is going to take this particular application with this particular command line arguments and run it millions and millions and millions of times across a lab of machines created just for you in the Azure cloud. So I have to find that application. Okay, so I want to browse. It's in the C app directory. Remember, we just uploaded it to C app. And there it is, Calendar Reader. So Calendar Reader is my sample application. I've uploaded it to the remote machine, and then I just find it, I click on it, and I say open, and there it goes. And command line arguments. So I'm running Calendar Reader exe, and what happens is this token test file will be replaced with a uniquely generated file every single time it runs. Today, Calendar Reader doesn't have any additional arguments. But if I had additional arguments, this is where I would put them. So I'm done here. I'll say next. Now we need to provide what we call seed files. So seed files, remember, are initial files that we use for testing the application. They're called seed files because they will be corrupted through the process of fuzzing and run millions and millions of times with different variations in order to find problems with the software I just uploaded. So I now need to upload seed files into this remote desktop. Okay, we have created seeds to contain your files. So I need to do what I just did, but for the seed files instead of the application. So there's the application. You just saw me upload into the application directory. Now I go to the seed file directory. I'm double-clicking on seeds. There's nothing there, but fortunately, I have locally a whole bunch of calendar files. Basic, bitmask. Previously, you saw me open up one of these with Notepad to show you what it looks like. All of them are very similar. And just as before, I'm going to select all of them. I'm going to copy them, and then using the magic of Windows and the magic of RDP, paste them, and they move all the way from my local machine up to the cloud. So basic, cal basic, all of these are moving up to the cloud. Great. And they're all in the C seeds directory, so I don't need to change it. So I just say next. The wizard then will ask you a little bit of information about your application. This information is used to help Microsoft Security Risk Detection get the best possible fuzzing for you by optimizing the way it creates the lab in the cloud. So first, can the executable be renamed and run in parallel? If I run Calendar Reader 1 and Calendar Reader 2, will they get in each other's way? So Calendar Reader, this particular application, yes. But you may have an application that it has some global state across the machine. If that happens, then you want to say no. Only one instance of the executable can be run at a time. For instance, at Microsoft Word does not like being renamed and parallelized. So that's a case where we would run one executable at a time. Does the executable run from scratch each time without persistent state? Yes, Calendar Reader is independent. Calendar Reader doesn't drop files on the disk. Calendar Reader doesn't change registry keys. Calendar Reader doesn't change global state. But some applications, your application may be among them, might write a file to disk, or you might change a registry key depending on what happens during an execution. So I'm going to say yes, each runs independent, but if no, you just click that, so then we know. And does your executable run entirely in one process or process tree? So here, Calendar Reader is one process. I would say yes, even if Calendar Reader forked the child process. But there are cases where the client server. Remember, this is an entire VM. You have the freedom to install whatever you want. If you want to install SQL Server on this machine and then have your application talk to SQL Server on the machine over and over again, you can do that. If you do that, you'll want to say no, there's out-of-process code. Next, it asks, does your application self-terminate? So Microsoft Word, again, doesn't self-terminate. You open up Word, it'll render the image, and it'll just wait, and wait, and wait, and wait. Calendar Reader, on the other hand, reads the calendar file and then closes itself. So I'll say yes. And my maximum runtime, that's really dependent on my application. Microsoft Security Risk Detection asks this because we want to be able to tell you not just when there's a security issue, but even when there's a performance issue. Maybe there's an input that causes your application to hang or to run for a very long time. Maybe you're running a service that is very performance critical, and if something caused that service to run for a very long time, that would negatively affect your customers. So here I'm going to say, if there's anything that causes the Calendar Reader to run for more than 5 seconds, even if it doesn't crash, give me a heads up. The wizard will then run the application and test it before letting me send everything off into the cloud. So I'm going to push this button and say I want to validate the job. Validating the job means I'm going to run the application with the command line I gave it on one of the seed files and say, does it crash or does it not crash? So let's see. It's validating. It's validating. Let's see what happens. Let's see if it gets through it. So under the hood, it's running Calendar Reader on one of those executables. And I can see the standard output, the standard error to help me understand what's working. So standard output, I'll take a look at that. And it says, great, I see this, and create calendar from file name input. That failed, but the Calendar Reader itself didn't crash. So I'm going to go ahead and say, great, let's push it. Let's make it go forward. And the final thing is submitting a job. The job is configured. It's ready for submission. Once I push the button, this session is disconnected, and I will not be able to reconnect to the machine. However, Microsoft Security Risk Detection Connect creates a mirror of this machine based on the exact virtual machine configuration I've created here. So all I need to do, create a lab in the cloud, start millions of test cases running just for me, is push the submit button. I'm going to push the submit button. 5, 4, 3, 2, 1, boom. Now, under the hood, Microsoft Security Risk Detection is taking the virtual machine. You can see it's already disappeared, and it's running it through a process to generalize the machine and create an entire lab just for you. And so if I see here up on the dashboard, I've clicked on the dashboard link again, and I can see that the list of jobs is gone from fuzzing, or gone from days to submit to a validating process. This validating means that this configuration I've submitted is going through a process of being prepared for creating a lab. The lab is being created, and then I will get a fuzzing status just like this, where millions of test cases are being created just for me. And then just to close, if you ever need to reproduce an issue on the exact same configuration as what Microsoft Security Risk Detection used to find it, you go to the open page here, so the open link, it comes up, and then you look at the progress link, and we see two things. One is the total number of inputs have been tested, so the metrics here. So this one has done 1.5 million tests since it was created earlier today. And then we actually have the remote machine connection, so we can connect to a virtual machine in the cloud with the exact same configuration as what you submitted. And that way, you and your colleagues can continue to work, you can continue to change things without worrying about losing the ability to reproduce critical issues. That's been a tour of Microsoft Security Risk Detection. Just to recap, today we showed the fuzzing portal. We showed the results, what you get from fuzzing, and how you can use them to identify really critical issues. We showed you how to create a new job and submit your own code, so now you can see it's validating. And we showed you how to understand, after the job has found issues, how to reproduce them. We hope that you get a lot of great value of Microsoft Security Risk Detection. And if you have any questions or any help needed, we are fuzzing@microsoft.com. Fuzzing@microsoft.com. Thank you.